Hello everyone, welcome back. In the last lecture, you have started about the observable and the corresponding operator. So in the today's lecture, we are going to see some of the observable and operator. Corresponding operator. This is position. The operator is r cap, momentum, then p cap, that is minus I h cut, gradient, t, kinetic energy, p square by 2m, that is t cap is equal to minus h cross square by 2m rad square, e, that is p square by 2m plus b r comma t is h cap is equal to minus h cross square by 2m rad square plus b cap r comma t Now L, angular momentum r cross p, that L cap is equal to minus I h cut r cross gradient. Okay. Next we'll see about measurement in quantum mechanics. Measurement in quantum mechanics. Measurement in quantum mechanics. In classical mechanics, any measurement does not perturb the system, but in quantum mechanics, the measurement changes the state of the system. That is, measurement in quantum mechanics distorts the state of the system. Measurement in quantum mechanics, perturbs the state of the system. The perturbation in measurement is also exist in case of classical mechanics, but this perturbation is so small that it can be neglected. Perturbation also exist in case of measurement in classical mechanics, but this can be neglected because it is so small. But in quantum mechanics, but in subatomic cases, we can't neglect these perturbations. So measurement in quantum mechanics changes the state of the system. Okay, that is when we do something, when we measure, then the state of the system will be changed. Take an example, that is example measurement of position of hydrogenic electron, that is position of an electron of hydrogen atom. Okay, when we do measurement, what to in order to measure the position of electron, we have to bombard the electron with electromagnetic radiations. We have to bombard the electron by electromagnetic radiation, that is photon of very small wavelength, electron of very small wavelength, in order to in order to in order to calculate the position very accurately. Okay, since the atomic orbit is of the order of 10 to the power minus 10 meter. So wavelength must be less than 10 to the power minus 10 meter. This small wavelength radiation have energy h mu, that is hc upon lambda, is equal to order of 10 to the power 4 electron volt. And we know the ionization energy ionization energy of electron in hydrogen atom is just 13.5 electron volt. So this high energy, this electromagnetic radiation will completely disturb, will completely knock out the electron out of its orbit. So this this high energy this high energy electromagnetic radiation of order 10 to the power 4 electron volt will knock out the electron from its orbit. That is, when we going to measure the position accurately, state of the system completely changes. State of the system changes. So we see or we saw the measurement in quantum mechanics changes the state of the system. In the theory we replace the measuring device by an operator that is, let's suppose a cap, by an operator. In the theory we replace it by an operator. When operator A operates on his psi, when operator A cap operates on a state psi, it changes it into one of its eigenstate psi of n. That is, psi of n is the eigenstate of operator A cap. Now the state psi can be represented by the state vector psi must be linear superposition of eigenstates of psi n. Superposition of eigenstate of A cap, that is A operator. That is, the any state must be linear superposition of eigenstate of A when if we operating operator A cap on psi. That is, we can rewrite that psi as sum of n into psi of n into psi of n, and like this. If the system is in the eigenstate of psi of n, अगर सिस्टम पहले से ही, हमने क्या कहा कि अगर एक ऑपरेटर किसी कोई भी स्टेट के ऊपर ऑपरेट होती है, अगर लेट्स सपोज इन ऑपरेटर ए कैफ operates on a state psi, then it will changes it this state of the system, this state vector, into its one of its eigenstate psi of n. Okay, one of its eigenstate psi of n. Now if 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 the system is already in one of the eigenstate of the system, then when a operates on psi of n, it will give an eigenvalues an, and the system will remain same. That is, there will be no change in the state of the system. Where, and we can also measure the a of n, that is the eigenvalue with certainty. That is, we can measure the eigenvalue with probability, with 100% probability. That is, we can measure with 100% probability. That is, this is the case. Now the energy of the system is represented by, and we know that energy of the system is represented by expectation value of the Hamiltonian operator. That is expectation value of Hamiltonian operator H cap, that is psi into H cap into psi into psi into psi. This is the expectation value of the Hamiltonian operator. Okay. Now we'll study about the complete set of commuting operators. Some important points to remember. Some important points are, that is, about commuting, some important points about commuting operators, क्या point है? That is, two observable A and B are said to be compatible if their corresponding operators commute. ये थी कुछ इंपॉर्टेंट पॉइंट कि अगर किसी दो ऑब्जर्वेबल सेट टू बी कंपैटिबल इफ देयर करस्पॉन्डिंग ऑपरेटर्स कम्यूट, अगर उनकी करस्पॉन्डिंग ऑपरेटर कम्यूट हो जाती है तो हम दो ऑब्जर्वेबल को हम कंपैटिबल ऑब्जर्वेबल कहेंगे. ओके, नेक्स्ट क्या है? नेक्स्ट पॉइंट क्या होता है? नेक्स्ट पॉइंट ये है कि अगर, दैट इज, इफ टू ऑपरेटर्स, इफ their corresponding operators does not commute, their corresponding operator does not commute, then these observables are called incompatible. that is here a cap b cap will not is equal to 0, that is they not commute. if टू ऑपरेटर्स, अगर दो ऑपरेटर कम्यूट नहीं होते तो उसकी जो करस्पॉन्डिंग ऑब्जर्वेबल्स है उसे हम नॉन कंपेटिबल ऑब्जर्वेबल कहेंगे। ओके, नाउ अगर दो ऑब्जर्वेबल कम्यूट हो जाती है तो अगर अगर if two operators like a cap and b cap commute, then they have common eigenstate. They have common eigenstates. If two operators a cap and b cap commute, then they have common eigenstates. Okay, and also if two operators commute, then then what will happen? Then the they can be measured. Then a cap and b cap can be measured simultaneously if a cap commute with b cap. A cap commute with b cap, then a and b can be measured simultaneously. If if a cap if a cap and b cap do not commute, they cannot be measured they cannot be measured simultaneously. And order of measurement order of measurement matters. That is how we will see that how order of measurement matters when two operators do not commute. कैसे, चलिए देखते हैं कैसे दो ऑपरेटर की जो मेजरमेंट है वो कैसे मैटर करती है। अगर what will happen that we are taking that a will operate, we are taking two operators a cap and b cap. Now at first we'll measure the a cap, that is a cap will operate on a state vector psi. Then what will happen? It will give an and psi of n, that is it is the eigenstate of a. Now when we operate on b cap on an psi of n, then now the eigenstate is an eigenstate of a cap. Now the state is the eigenstate of a cap, and this will give some different value. This will give some different value alpha. It will give some different value alpha, and it will change that psi of m, where psi of m eigenstate of b cap. This will give alpha and psi of m. But when if we operate b cap on psi of psi, then what will happen? अगर हम b cap को पहले रखते हैं तो क्या होगा, b cap को ऑपरेट करते हैं तो क्या होगा, तो क्या हो जाएगा, b cap will operate, that will give something that is bn, it will give bm and psi of m. And when we again operate a cap on b cap psi, then it will operate on a cap, bm of psi of m, then it will changes it to one of its eigenstate and the different value with different value, that is beta psi of n. Here alpha is not equal to beta, that is the result are different. So in this case, in the case order of measurement matters. Now if two operators of commute, the case 2, two operators are now commute, two operators
A cap and B cap are now commute. Then what will happen? They have common eigenstate. Then they have then they have they have common eigenstate. Common eigenstate. Then what will happen? Then what will happen when A cap will operate? A cap will operate on psi. Then it will changes. It will give an to psi of n. And when B cap will operate on B cap will operate again A cap psi, then it will give, that is B cap on operating on an and psi of n. Now here the psi of n is also eigenstate of Bn. Psi of n is also eigenstate of B cap. That is psi of n is also, you can write that psi of n also eigenstate of B cap. So what will happen? Now the result will be, that is something that will give alpha into and psi of n. It will remain in that state. And again, next, when we do measurement, at first the measurement we measure, now we are going to measure at first the B cap on psi. B cap on psi. That is B cap on psi. Then what will happen? That will give Bn and psi of n. Now when we operate A cap again on Bn of psi n, then it will give something alpha into psi of n. Alpha into psi of n. Okay. Now the results are equal. ओके, थैंक यू। आज के लिए इतना ही। तो अगर ये लेक्चर पसंद आ रही है तो प्लीज़ लाइक शेयर एंड सब्सक्राइब करिए।